Thank you for joining us this afternoon. We've already got 38 people online, and in fact, I've got some more people to let in. Thank you very much for joining us. Today, we have a visitor from France, Dominique Cardon, who is going to first talk for about 2 or 3 minutes about herself and why she's interested in the history of dyes, and then we'll start the talk properly once everybody is in. So over to you, Dominique.
Thank you very much for this kind introduction. Ladies and gentlemen, good afternoon. I am a historian and archaeologist who specialized very early in research into textile and dyeing techniques, and which is a very aha.
Are you okay?
Oh yes, which is a very good example of interdisciplinary research field. Actually, being primarily a historian and archaeologist was very important for me because it's really through the amazing advances of archaeology and archaeometry too that we now are able to begin realizing how incredibly early humankind managed to discover how to apply organic colorants to a variety of substrates. And this knowledge, which is now much much improved by the combination and contribution of other sciences and analytical techniques, allows us to draw some inspiration, which I believe will be very useful now and for the future. One of the early examples of such important contribution of archaeological sciences is this recent discovery of the fact that already in Paleolithic times, thousands of years from now, people already had realized the coloring power of some plants and were using some strengths and some techniques to extract these colors from these plants. And as you can see from this pebble, from which were extracted through micro fissures, a group of organic remains at the bottom of which were crushed fibers of wood. And this is very telling about this quest for color, because as you know, wood is not an edible plant. It's not used to cook. It could have been used for medicine too, but in any case, the very fact of crushing it allowed to extract the indigo color, the indigo molecule from the colorless precursor. But we don't have proofs because we don't have textiles. And the reason why the earliest textiles we now have discovered are much later than this very early example I've just given. Why? Because like other organic remains, textiles and textile fibers can only be preserved in very limited, narrow environmental conditions, including a dry environment, very dry, constantly dry, or extremely cold, or in anaerobic conditions underwater. So it's only only a few thousand years ago that we start discovering textiles. But as you can see, we can already this very, very early textiles are already showing an extraordinary sophistication, I should say, with this example of the earliest known indigo-dyed textiles, which is already showing several shades of indigo arranged in stripes and checks. And this leads us to the question of we are be talking of an indigo dyed textile. How do we know it's dyed with indigo? Uh, at that early stage, what can we do to obtain all this information from a fragment of textile? I'm going to give you a personal example from a series of sites I was working on with the Franco-Chinese archaeological mission in Xinjiang at the northwest of China. These textiles were preserved by the extreme dryness, drought, and cold temperatures of the Taklamakan Desert, very cold in winter, very hot in summer. And I worked on particularly on the earliest site, the North Cemetery, in which only wool textiles were found with a predominance of pigmented wool of all kinds of shades of brown to nearly black to grayish and beige, but already the proof of a selection, the beginning of a selection of the sheep fleece for white. And why white? Because they wanted to have bright colors. And as you know, to dye on a white ground, you get clearer and brighter colors and pigmented fibers. And so the method is, what do you do when you find that type of very well preserved red dyed wool? The first very small samples which were analyzed immediately guided us to look for a plant red, not an insect red like cochineal or kermes. So we had to look for something like some species of rubia, madder, or gallium. And so I went for field missions. That's where botany comes to the help of the historians and archaeologists. Botany and ethnobotany, since not only you go by yourself at random in a kind of environment you don't know, which was the case for me around the margin, southern margin of the Taklamakan Desert, but sometimes you can be helped by showing photos and asking questions from people, local people. And in that case, I was very lucky because very soon I met a local informant who led me to a place where some dyer's madder was still growing. At the stage, it was early spring. I couldn't be sure it was dyer's madder, but later on, by cultivating it, it was very obvious it was the same, not the same, quite the same, another variety of dyer's madder, Rubia tinctorum. But the first analysis we had performed showed that there was alizarin, so it was a madder type red, but in such proportions that whatever reproduction samples I could do with this local madder, I could never get the same high proportion of alizarin, which in that type of cases, you are led to look for more plant samples. So I went looking in other parts on the north side of the Taklamakan Desert for rubia, other rubia species, and for bedstraw species, because as you know, bedstraw roots can give the same type of orangey reds as madders. In the end, it was chemistry and the amazing advances of analytical techniques which brought us closer to an answer with two types of chromatograms performed by another team of colleagues from the National Museums of Scotland, who found that there were actually two types of madder reds in these archaeological textiles. One which gave proportions, because at the stage as we are working at now, we can be more precise than when I started working in that field, and it's a question of proportions of the different components of matter, which can be completely decisive. And so in that case, there were clearly two types of, either two types of plants used, or two types of ways of managing a mother type plant. And in any case, none of the many samples I could dye to compare with the archaeological samples was getting anywhere close to the proportion of alizarin that there was in these archaeological textiles. So the other hypothesis that must be addressed in that type of situation is maybe it was the same plant, or maybe there were two plants, but in any case, they had managed to find a way to deal with their modern baths and their dye baths to enhance the proportion of alizarin and to sometimes get rid or lower the proportion of the unwanted components. And so this leads to the other question. How can we know how they were dying? What processes had they found? And for this, we have to rely necessarily on written documents, on epigraphy, on the epigraphical science. And what is sometimes not enough taken into account is that dye recipes very often are parts of the most ancient documents on chemistry. They are, from the beginning, dyeing is one of the major preoccupations of chemists, as show these two very early texts, the Sipar dye text and the Stockholm papyrus. And as you can see, they both talk and they both describe a recipe to imitate the true mollusk purple obtained from Muricid seashells. And this, at this stage, when we are getting into history with written sources, it becomes easier. Our task becomes easier because we can then compare the archaeological evidence with these early texts. And again, I'm going to give you an example from personal research. I was invited to study the textiles in a series of Roman fortresses, presidia, which were built along the caravan roads between the Nile Valley and the Red Sea. And the interest of these fortresses is that you have hundreds of textiles there preserved in the rubbish heaps of the presidia, which gives some statistical value to the studies you can do on these textiles. In that case, it made it quite obvious that these texts about the imitation, these recipes about the imitation of purple with plant sources corresponded to a real fashion or a real popularity of the color purple among Egyptian people and the soldiers who were coming to Egypt at that time. As you can see from this series of purple ornaments on the most popular and most used type of garment, the tunic. And you can find this on very beautiful comparisons, documents which are contemporary, the portrait, the Fayum portraits, with these two examples. One on the left is an imitation of purple, and on the right you have purple, which is a combination of true mollusk muricid purple and with a shading, let's say, towards a reddish, more reddish, through the use of some kermes insect. And again, we are faced with an example on the left of a type of dye which doesn't correspond to any plant species known. In no madder or no bedstraw root, you will find 95% of purpurine. So it's obvious that at this stage already there is a great expertise and great sophistication in the art of dyeing, which makes us very proud. You know, dyers of the present time must be very proud of their craft. But to know more and to what was not the case in these times, you had lots of garments to dye, but on each of these tunics you have very little dyed ornament. What becomes very interesting is in the medieval ages in Europe, with the emergencies of the wool broadcloth industry, which was the first big industry in Europe and probably in the world, we see dyes and dyeing getting to really big scales. I give you only one example, but many other urban digs, archaeological excavations in Central Europe, in cities of Central Europe, or even in London on the banks of the Thames, have brought forth hundreds of textile fragments. And what is very obvious is that they nearly are all dyed. The proportion of undyed ones is not at all as big as has been written in some historical books. People wanted to be dressed with colors, you know, as much then as now. And so we have also other proofs of that in other type of written documentation, the account books of dyeing companies, like this, preserved in Pisa at the moment. I was part of a big collaboration to study their archive, and we have 3 account books of this company of dyers, and the amount of dye plants they were using is absolutely staggering, you know. I only give you the example of the yellow dye plants, weld and sowert. Sowert was collected in the wild, in the mountains of the Apennine, and weld was already cultivated on a big scale around Bologna, for instance, and further north. And so you can see that with 11,315 kilograms of dry plant, you can go to a long way to dye a lot of broadcloth. And together with these proofs of a massive use of dye plants come for the first time, really precise recipes. So precise that you can reproduce them, actually. You have the volumes, the quantities, the length of time you have to wait for the fermentation of the wood to proceed, etc. And you can reproduce this process and obtain this beautiful range of blues, which was dyed by John Edmonds, the late John Edmonds, an English friend of mine, with whom we collaborated to reproduce the recipe I was showing in the previous slide. But the problem at that time is that we have very few no, actually, we have no name of color which is illustrated by a recipe. Either you have the recipe with the name of color, but you don't have the sample, or you have a sample with the name of color, but no recipe. These are commercial documents. They are just orders for this, so many pieces of this rose or this green or this scarlet, but no recipe to go with it. It's only from, I mean, in the present state of research, as far as I know, it's only in the 18th century when we get really the ideal type of document in which you have the name of the color, the sample which shows what this name of color corresponds to, and a precise recipe. I give you two examples from Languedoc. They are the only one for that period anyway. And in London, you have the Crutchley Archive preserved in the Southwark local history library and archive, on which I was invited to work. The only trouble with the Crutchley Archive is that you do have the name of the color. It's usually written in the recipe. The recipe is perfectly precise and clear. The only problem, you have the sample too, so you can do spectrophotocolorimetric measurements and use this precious and rare document to better understand the recipe, but you very, very seldom have the weight of textile that is being dyed. And so you cannot you cannot be sure of the proportions. It's just a question of trial and error, but you don't, I think I have spotted about 3 or 4 or 5 recipes where you can have the real weight. So it's really in Languedoc, thanks to the very strict, detailed regulations devised under Louis XIV by his minister Colbert, that we have really statistics, reliable statistics and detailed measurements for the different qualities of broadcloth, which allow us to really fully realize the amazing scale, really industrial scale at which these dyers were working. You know, yeah, they had to dye about 8 to 12 pieces of these dimensions a day. Without counting any holiday. It's just counting 365 days in a year. So, and also the quantities of colorants they had to plan, to buy, and have at hand to do that. All this story and all this evolution was brutally and very suddenly interrupted by the discovery of the first synthetic colorants. Everybody knows this anecdote, and also it's a kind of convention to date this first discovery from 1856. But there's no question that it was a real breakthrough. It was a conquest of humankind that must have brought joy and to millions of people with the democratization and diffusions of colors on all kinds of fibers, and a source of great pride and sense of power for the dyers. So there's no, in my mind, there's no opposition, there's no war between synthetic colorants and natural colorants. The only problem is that now we must ask ourselves if it's still sustainable, a massive production of synthetic colorants. And the fact that research into natural colorants completely stopped with the triumph of synthetic colorants is now a kind of major problem for us, for research into the development of a further development of natural colorants and for their applications at a bigger scale. And I keep saying that if as much investment, financial investments, and scientific investment in research were were dedicated to research into natural colorants, it would go quicker, and the field would progress quite as fast as synthetic colorants progressed in the second half of the 19th century. Also, there's no question that going back to a bigger use of natural colorants is not without its dangers, and that it has to be considered with the same wisdom and care as the use of synthetic colorants nowadays. And the first condition for such a development of research and applications is that we now must completely change our minds. You know, we have been accustomed to deal with colorants which are made from one molecule, and that implies a simpler way of understanding how to use them, especially the colorants which were developed precisely for one application, for one type of fiber, which can be done when you are doing chemical synthesis. With nature and natural colorants, the approach must be completely different. We have to understand what there is, in what proportions, and what we can do with these colorants and their proportions. And so the first people I met who were fully aware of this of the difficulty and of the necessity of working together and of having interdisciplinary collaborations was a group of researchers into dyes in history and archaeology. We were talking about some of them earlier on with Peter before I started talking, and you certainly recognize some of them on the photo. You know, it has been a kind of like a kind of family for me. And I should say that after 45 years now, nearly, this group has produced a quantity of breakthroughs in nearly all fields of research into natural dyes, where it's true from the historical point of view, with discoveries and comments on unpublished manuscripts. And it's particularly true from the point of view of analytical techniques, where our chemist colleagues were coming with reports on new ways of identifying minute quantities of colorants, or of being able to analyze the colors on a textile which cannot be sampled because it's too minute or too precious. And this group has really been contributing a lot to progress in this very broad and interdisciplinary field of research. Another other groups, should I say, that have been very important and useful. First, to prevent natural dyes and traditional dyeing techniques from being altogether forgotten. Traditional dyeing techniques are an endangered type of heritage in many parts of the world. More and more as time passes on, and it's only in the recent years that people have realized how precious they are and how essential to human knowledge these dyeing techniques are. And this group of, this series, should I say, this series of international symposium for which I was invited by UNESCO to act as a scientific director. This symposium have had the wonderful usefulness of bringing together people who very seldom meet, namely scientists of all concerned scientific disciplines, but also practitioners, professional dyers, traditional dyers from many parts of the world in workshops which were demonstrating these dyeing techniques, doubly dyeing. Textile designers, artists, and industrial people who are coming now more and more, which is quite encouraging, I find. I also try to do my bit by publishing, trying to collect all available information from the different fields of research into books in French or in English, where people could find basic information on the most important, or let's say most important from a global point of view, plant sources. And now, the result of all this research of several, about 30, 40 years of interdisciplinary research and activity, now we more or less understand what could be done and how it could be done. And of course, it involves development at bigger scale of the major historical dye plants. Major because they had been selected for their beauty, but also their fastness to washing and to light. But this doesn't prevent from trying to find new natural dyes, meaning either putting to bigger use some local or traditional plants which have been more or less discarded by major industries, or completely new sources of colorants. We must not forget that at the same time as we are exploring some flora in various parts of the world, while destroying them at a greater speed. Among these plants which we are trying to discover and describe and whose application we are trying to understand, there are quite interesting dye plants. I'm going to give you one example. A major breakthrough was also the way to use these plants in a completely different new line of production. The example of new dye plants is quite recent. That is a PhD thesis for which I was co-following or not directing, but advising, let's say, and which turned out to propose, among many other results, very interesting results, to propose new dye plants, actually, including this plant which dyes green without a ground of blue, which is not so usual in the world of plant dyes. From the point of view of the techniques of production and extraction, the major breakthrough was the production of colorant extracts. Instead of reducing dye plants into fine powder or making decoctions, boiling them, this breakthrough consists in extracting the colorant and discarding the cellulosic or fiber part of the plant, which makes the totally soluble extract usable in any kind of industrial dyeing machine. And at the stage at which we are, where natural dyes are used at much smaller scale than they used to be in pre-industrial and pre-synthetic times, it's very useful to see that some makers of machines are adapting to the scales at which small industrial scale or high craft scale at which natural dye textiles are now produced. And so you have two examples from our country, but I suppose you could find equivalents in the UK. What I now wish to emphasize is a unique contribution that these dyers books with samples make, because so I tried to make them more accessible. Most of them were only manuscripts, so I've been starting to publish them, and to publish them in a practical way, you know, translating the recipes into proportions per the weight of wool to be dyed. These are based on treatises or memoirs which only deal with the dyeing of wool, but there exist some other instances for cotton and silk. And from these publications, we can start to understand how the type of empirical knowledge of chemistry these dyers had. They were classifying their colors into blue, understanding how to manage a biological reduction vat, such as a wood vat, strengthened with an addition of exotic indigo. And they were doing that at massive scale, around 4,000, 5,000 liters vats, which is considerable, and producing the whole range of blues, which they needed not only to have blue shades, but also to produce the purples and the greens, some grays, and all the fast blacks. They also understood their difference with all the group of colorant mordant colorants, which need a chemical link with salt mordants, metallic salt mordants, to be strongly bound and become fast dyes on the different types of fibers. So red, with a selection of the two fastest reds known at the time, madder and cochineal, and the wonderful range of colors they were obtaining with them. Yellows, with the selection of the fastest among yellows. We all know that yellow dye plants tend to be less fast to light than other colors, and so they were selecting for flavon-rich dye plants such as weld. Fawn, which they understood did not need mordanting with metallic salts, because they were all mostly composed of tannins, with a variety of a colorant combined with the tannins, and a huge variety of shades of beige and browns. And of course, the king color for them was black. Their fast blacks were obtained on a ground of blue, as I mentioned earlier, but you have a variety of blacks which either include mordanting and dyeing red on top of the blue ground, or playing on the cocktail of tannin plants, and everything in both cases. Everything was finished with the reaction of tannins with iron salt to obtain black precipitate and very, very fast blacks. So you have an example, and the grays were just more diluted versions of the black. The additional usefulness of these documents, which are very rare, as I said, is that the presence of the samples allows to use another tool at its best efficient level, that is by measuring all the samples with a spectrophotometer and giving chromatic data for all these colors and shades I was mentioning. In the CIELAB system, which is the most widely used among people, industrial people included, dealing with the history of colors. And so we used the color of these samples as a way to compare between series of documents which are not preserved in the same place and cannot be displaced. Also to start understanding what all the samples that are still preserved but have no color names, how they could be called and perceived by the dyers and their customers. And also they are mostly used as a tool to check the accuracy of the reproductions which can be made with natural or synthetic dyes. And in this way, they become a new source of inspiration for designers and textile creators. As a way of comparing, I give you the example of comparison between madder reds done by Languedocian dyers and the Crutchleys in London. And to our amazement, you can see that what the Crutchleys called red, or what the Languedocian dyers called rouge, it's a madder red, which is really very, very close, since you see down there that most are around 1 as a color difference, a delta E color difference. And as you know, under 1, the human eye cannot perceive the difference. So the expertise of these dyers is a kind of treasure that can be used nowadays by combining experimental archaeology and colorimetry. This has happened for the last 2 years in workshops that I give with a colleague of mine to people wanting to train as professional dyers, usually on a much smaller scale than we have studied for the moment, and measuring all the samples, both on the historical manuscripts or on the reproductions we managed to produce, following the same classification in 5 primary colors as in the manuscript. And the fact of reproducing more or less accurately, preferably very accurately, these colors allows us to submit the reproduced samples to the usual tests that are used at the moment in industry, especially the light fastness tests. And the first results are extremely encouraging. As you can see, we get blacks or reds and some blues, which are at the top of the light fastness of the present methods of tests. And it is so encouraging that it's now being adopted. It's a kind of approach which is being adopted in other countries, like in this design school. It's part of the University of Segovia in Spain. And Professor Juan Ramon Lopez Odriozola has been working with his students on the reproductions of these colors based on one of the manuscripts I was mentioning. Same again in Lisbon, in the University Nova of Lisbon, where they have been doing writing several articles, chemical articles, based on their study of the colors, either reproduced or studied with non-destructive methods from the manuscript. And that's it. That's news of the of what's going on at the moment in the field of natural dyes. Thank you very much.
Thank you very much, Dominique, for an absolutely wonderful talk that ranged across the whole of history, from the very earliest time to today. So thank you very much for such a tremendously wide-ranging talk. I might just mention two things here before we go any further. The first is that Anita Kay gave a talk about the Crutchley Archive 2 years ago, and Bree Corin gave a talk to this group a year ago on Tyrian purple. So you're following in the footsteps of some of
Very
your
good. Very
colleagues.
good.
It was also very interesting to hear about the Florentine dyes. Now,
Yes.
now I have two questions myself. I have a few more questions, but I have a couple of questions myself. They basically involve the beginning and the end of your talk, in a sense. The first one is, I find it amazing, but one of the earliest dyes you can find is madder. From the very beginning, it seems the very best dyes were already known. Indigo, and then maybe a little bit later, madder, and then maybe a little bit later, indigo. Now, how did they do this? How did they manage to find them? I mean, surely there must have somewhere been a lot of trial and error before they arrived at these wonderful dyes.
Yes, you are absolutely right. What I really want to stress is that the earliest documents we find are already showing an expertise which must have resulted from thousand more years of trial and error, as you say. And this trial and error manages to select the best dye sources. But on the other hand, you can say that if we find indigo and madder in the earliest example of archaeological textiles or archaeological remains, botanical remains, it's because precisely they were fast. Probably there were lots more colorants that were lost. There's another instance, I had no time to give more examples. Another very ancient example is the finding of an extraordinary proportion of an alkanate type plant in the Nubian desert. It's about 8,000 years old. And after the seeds of the most edible, the most important edible plant on that site, which was sorghum, the next one was the seeds of a plant which is not edible and which is not used for eating, or which is Arnebia hirsutissima. It's an alkanate type plant. So it's obvious that they were using its root, but the root itself has not been preserved, but it's a massive quantity of seeds which shows that they were using this plant. I have found that also on Neolithic sites in France where no textiles are preserved, but the dye is not, and it's not possible to identify it, but you have amazing proportions of seeds of dye plant, and then that tells you that it was being selected and valued. And probably some of the anthocyane sources of anthocyanins, like berries or flowers, just were not preserved because of the environmental conditions.
Okay, fine. My question at the other end of your talk is about the use of natural dyes to replace synthetic dyes. I mean, you gave a lot of attention to that. I've just completed a history of polymer science, and then the last chapter of it deals with the future of polymers. I say that we've got to bear in mind that if we wanted to replace polymers, synthetic polymers, with natural material, wool, for example, or rubber, it will be enormous quantities of land required to do so. For example, I calculated that for wool to have enough sheep to replace all the synthetic wool we have made these days, you would need an area the size of Australia all over again.
Yes.
Now, so is this a problem for natural dyes, or do they not take up that much land?
No, I recognize it's an argument which is very often mentioned as a problem, but the producer of colorant extract I mentioned in my on one of the slides has calculated from about 30 years of experience of producing colorant extracts and advising industrial people on the best practice to use them, the right proportions to use them. And she produced 2 slides for an international symposium in Helsinki last year, where she produced the actual result of, of her research. And the result is that if you wanted to dye all the textiles made with natural fibers, with natural colorant extracts now, it would take the same surface, the same superficie of land, agricultural land, as what is now being used for planting tobacco. And if you wanted to dye with natural dyes, all the textiles that are being produced, including synthetic fibers, in the proportion she has experienced, you would need a superficie which would be equal to the present day territory of Austria, which is not the whole Earth, So this calculation has to be done on real experience and has to be really published and diffused. It's not true that we cannot grow. And as I said, you must also, I didn't have time to talk about everything, in 3/4 of an hour, but you also have to take into account the possible use of all the wastes of other uses of plants. And that's the main field of research and development at the moment, using, for instance, the leaves of a plant which is normally used for its root or that type of thing. I can't give botanical names because it's still confidential, and there are going to be patents taken on this reuse of plant waste. So if you take that into account, plus all the plants which have not been selected and which have been proved by various PhD theses I directed or co-directed to be interesting sources of colorants, it's much less pessimistic than was perceived until now.
Okay. Okay, fine. Um, and a matter of interest, I have a large indigo plant in my front garden, but I've never tried to make any dye from it. It's not Tintoro, it's Himalayan East, it's a Himalayan indigo, but I gather you can make dye from it if you try. Okay, now let's ask the other question. We have a question here about what were togas dyed with. Now, of course, this raises an interesting point about imperial purple, because as I understand it, imperial purple of the Roman was not purple as we know it today. It was more of a dark red.
What was the question exactly?
No, sorry. Somebody asked about the dyeing of Roman togas.
Ah, yes, yes. Yes, in with these sites I showed you in the eastern desert of Egypt, we have multiply by something like 10 times the number of archaeological textiles dyed with true purple that were known before that. Why? Because it turns out from these very modest sites, you know, they were only modest people, not rich, uh, but it shows you that we're reusing, recycling, and using up. That's something I didn't have time to deal with enough, but there's an amount of economy and ecological mind in a way in these ancient dyers, which is surprising. You know, they never waste a vat or a dye bath. They reuse it. After a red, they get, I don't know how many pinks. And in the case of true purple, which was the most precious because it needed a single vat needed thousands of animals. And they were using it, using it, using it. At one stage, they get debrominate because debromined because the most brominated molecules of true purple get fixed onto the wool first. So they get a vat which is getting bluer, giving bluer and bluer shades. And that's partly why on this slide I showed you have an addition of kermes. When it was getting too blue, they were adding either kermes or species of cochineal they had in Egypt or madder. And so you find also, maybe in the slide where I was mentioning the colors, anything from grayish purple or pale pink or pale mauve, you may identify as true purple if you analyze it, you know. It was not the color. Of course, you could have very bright true purple worn by an emperor or a very rich person. But you could also have a simple quarry worker, and this is something we know, who was able to pay for the small amount of wool dyed with true purple from a nearly exhausted vat and wear it on his tunic. And everybody would know that it was still true purple. You know, there was a kind of knowledge of the possible grades, and there were all kinds of prices for true purple, which have been studied by colleagues who deal with epigraphy, for instance, in the Diocletian stones from the Diocletian edict. So true purple was very precious, but it was also diffused through this kind of process of exhaustion. I don't know if
Okay,
it's a good answer.
yes, yes, they're good. I have a question here from Isabel Marlequez in Portugal, who asked, what is the blue, the Tuareg, you know, the Tuareg, the Berbers of North Africa? They apparently paint their body blue. And she's asking, what would that substance be? Would it be a pigment or a dye? I don't know if you're
Um,
familiar.
That's a problem of indigo, isn't it? So if you dye really with indigo in a vat that makes it soluble in an alkaline environment at the right temperature and at the right pH, you do a dyeing, and then this is very fast. It can, all the parts which have not been completely solubilized and fixed into the fibers or onto the skin can rub off. But what the Berbers in North Africa do is that they rub indigo pigment on their face, or they purposely don't rinse and wash completely their indigo dyed clothes to benefit from the healing properties of the indigo pigment. So what's on your skin or what rubs off is pigment. What remains on the textile is a dye, the dyed part.
Right, okay, good. I have one more question. I think we should try to draw this to close fairly soon. But I had a question about whether these natural dyes can be used for paper.
Can be, pardon?
Can the natural dyes you were talking about be used for dyeing paper?
Paper? Yes, but yes, I have trouble hearing you, but I think I understood paper. Yes, of course. Yes, yes. There have been lots of applications of indigo, for instance, to paper and to other substrates like wood or bone or yes, it can be used.
Okay.
I mean, they obviously paper being made from cellulosic fibers, you would have to use techniques which would be similar to dyeing cotton or linen. But otherwise, they apply. Natural colorants can apply equally well.
Okay, well, I think that's a good point to stop, Dominique, and thank you again for a wonderful talk. It was nice to hear John Edmund's name mentioned. He once gave me some woad seed to plant, and I did plant them, and I did get the plant, but again, I never actually got around to the dying part of it. But they're very, very good. Thank you very much for talking to us.
Thank
I'm
you.
just going to talk briefly now to the audience as a whole. We've got a talk next month by Kirsten Hall, who you may remember spoke to us a few years ago. He's going to be talking about Friedrich Meissner, who was one of the people who developed the chemistry of DNA. So it's about the origins of DNA and the early pre-crystallographic history of DNA. And he'll be talking to us about that on the 18th of November, which of course is the third Tuesday of the month at 2 p.m. next month. And then
Okay.
don't forget, at Christmas
Thank you.
on the 16th of December, we're going to be having Colin Johnson, who used to be head of technical in Cardiff, talking about recreational chemistry. So I'm sure that will be jolly exciting talk as well. So please come along, 18th of
So,
November, and don't
uh,
forget 16th of December as well. So meanwhile, please go away and enjoy your afternoon, and thank you once
goodbye.
again for coming. Bye, everybody.
Bye. Goodbye.
Bye. Bye.
Goodbye.